Good evening, guys. I hope everyone is doing well and everyone can hear me loud and clear. So we're going to start with today's session. But before we start, let me just welcome everyone. Welcome to the learning space. Hello, everyone. A warm welcome to all our amazing matriculants joining us for the learning space exam prep sessions. Today, we are diving deep into analytical geometry, trigonometry, and Euclidean geometry, breaking them down into simple terms, right? And boosting your confidence for those mid-year exams. And guess what? We are back again on Thursday with an epic paper one session. Whether you're joining us on Zoom or TikTok, make sure you are ready to learn and engage. And please do ask any question. This is your chance to strengthen your skills for free with expert guidance. Don't forget to subscribe, like, and share our content. Help us grow our community so we can keep bringing you top quality tutoring sessions. Spread the word and tag your friends. Let's ace metric together. We're going to get started. Okay, if you know of your friends that would benefit from the session, please do share the link with them. Right, so this session is starting now at 6 o'clock and we are going to end at 8 o'clock. Make sure that you do have pen and paper because there is a lot of writing that we need to do. If you have questions, you are more than welcome to post them in the Q&A section, okay? If you're watching from TikTok, please do post your questions in the chat. All right, then I'm going to keep my video off just so it can conserve data and we don't have network difficulties. All right, I'm going to share my screen and then we are going to start with today's session. Okay, perfect. So we are starting with analytical geometry. There are 3 topics. So we're going to spend roughly 40 minutes per topic. Okay, let's get started. We're not going to deal with the grade 11 or revision of analytical geometry. If you really need to revise grade 11 analytical geometry, there was an awesome session that I had yesterday with the grade 11s and that was recorded. It should be up on our YouTube page. Make sure that you do watch that. Right. So for the sake of time, we are going to get started. So we're going to start with circles. That's the new thing that they introduced in metric, right? So we have a circle with a center at the origin, okay? Now we know that the general equation for a circle is given by x minus a all squared plus y minus b all squared is equal to r squared. But now, what happens when the circle is at the origin, right? The circle center is at the origin. The origin, we know the coordinates of the origin are going to be 0 and 0. This is then going to make our a0 and our b0, making the equation x squared plus y squared equals to r squared. And this reminds you of something, Pythagoras theorem. Okay, another thing that is very important that we've learned in grades 8 and 9, we know that a diameter is 2 radii, right? Then this one is quite easy because we know this is the x value of the center and this is the y value of the center, and r squared is, so r would be the radius, but the equation is x minus a all squared plus y minus b all squared is equal to r squared. Moving along. Now, what would happen if we move the circle up and down, left and right? The center coordinates are going to change. As you can see here, we moved it to the left and we also moved it some units down. That's when we are going to have an equation that looks like that. A and B are the center coordinates, okay? And then we know that this point P is on the circumference of the circle, right? Now let's move on. Here's an example for us. Determine the center and radius of a circle with equation x squared plus y squared plus 32x plus 16y plus 240 is equal to 0, right? So how would we deal with a question like this? What we need to do is, first thing, complete the square, right? And how are you going to complete the square when you have x and y? You're going to complete the square for x and y separately. So you're going to keep the x's together and the y's together, right? How do you then go about completing the square? You have and you square the coefficient of x and y respectively, not x squared, not y squared. Then you add the answer to both sides of the equation. And then the last thing that you're going to do is you're going to write out your square brackets to get the equation in the form x minus a all squared plus y minus b all squared is equal to r squared. Then let's try to then complete that square for this equation, okay? We're going to do it together. If you've always struggled with completing the square, please make sure that you pay extra attention now. So the equation is x squared. I'm going to say plus 32x. I'm going to leave some space there. Then plus y squared plus 16y is equal to negative 240. Okay, I just grouped them and then I took the 240 to the other side. It became negative. Now, let's follow the instruction. Half and square. Half and square the coefficient of x. So what is the coefficient of x? This is the coefficient of x. This is the coefficient of y. So check what we're going to do. X squared plus 32x. Then we're going to say plus what? Plus 32 over 2. That's half. Squared. Plus what? Y squared plus 16y plus 16 over 2 all squared is equal to. Whatever we do on the left-hand side, we also need to do on the right-hand side. So we have negative 240 plus 32 over 2 all squared. Then I'll say plus 16 over 2 all squared. Okay. Now, when we're here, all we need to do is we need to write our empty brackets squared plus this second bracket is going to be for y, and our right hand side there is going to give us our r. Okay, make sure that you are with me. I'm going to try and slow down so that you guys are following every step of the way. And remember, if you have questions, please feel free to post them in the Q&A section or do post them in the chat if you're watching from TikTok. Okay, let's carry on. So we have positive and positive, and it means that we have a plus in the middle. Our sign is going to be plus. Now, we're just going to say square root of x squared, which is just x. Okay, now what is 32 divided by 2? That's how much? That's going to be 16. Then for the y, take the square root of y squared. That's just y. We have plus and plus. Our sign is going to be plus. What is 16 divided by 2? That's 8. We took the square root of that as well, where this canceled that. The same thing here. The 2 cancel that. I hope everyone is with me there. If you're not, remember to use the chat to ask any questions. And then for the right-hand side, all we do is we add everything up. We are going to get 80, 80. And then it means that the center coordinates are going to be negative 16 and negative 8. Our r is going to be the square root of 80. And just like that, we have completed the square. It's a very simple task. I'll give you 10 seconds to copy it down. Let me just zoom out so you can see everything that we did there. You can just take a screenshot to save time. But the recording will be made available to you guys. We are going to post it. We're going to post this session onto our YouTube channel. All right, perfect. Now let's move on. Now let's deal with circles that touch. Okay, so when we say circles are touching externally, what we mean is that the distance of center 1 and center 2 is equal to R1 plus R2. Okay, but let me just address the chat first. I think there's a question. Okay, somebody's asking me to explain the second step. Let me just go back up quickly so we can look at that. Okay, there's a lot happening here. Let me just erase this. Okay, because we're completing the square, remember what the rule says. It says we need to halve and square the what? The coefficient of x and y. So what is the coefficient of x? This is the coefficient of x. Let's find it first. It's 32. What do we need to do? We need to halve it, and then we need to square it. So I said 32 divided by 2. That's half. Divide by 2 is the same as multiply by a half. And then we square it, hence the 2 there. We have to do the same thing for y. And what is the coefficient of y? It's 16. We take it, we divide it by 2, and then we square it. Now, because this is something that we've added on the left-hand side, so we've added 2 things on the left-hand side. They were not there to begin with. We need to add them on the right as well. So whatever we do on the left, we need to do on the right-hand side. I'm hoping that is clear. And then from there, we just write it such that we get the equation of the circle. Okay, hope everyone is covered there. Yes, the lesson is recorded and it will be made available on our YouTube. We will share the link to our YouTube. Okay. Back to circles that touch and circles that do not touch. Okay, so if we have this kind of a diagram here, right, and these circles are touching externally, so they're touching at one point there, what we're going to do to prove that they're actually touching externally is we are going to find the distance of center 1, center 2. Right, so let's say these maybe were coordinates. I'm going to make random coordinates. 3 and 5, something like that. For us to find the distance between the two centers, we're just going to use the distance formula. This is distance C1, C2. Now remember their circles, the radii have a value. So remember the plural of radius. So it's one radius, and it's 2 or more radii. Not radiuses, but radii. Coming back, so if the distance between center 1 and center 2 is equal to the length of radius 1 plus the length of radius 2, then the two circles are touching externally, right? Now, if they're touching internally, it means that the distance between C1 and C2 is equal to R1 minus R2. So just be aware of that if they ask you a question like that. Okay, those are the tips that I had for you. Then we are going to get started with today's work. Okay, so make sure that you do attempt these questions with me. So here it says the diagram shows the circle with equation x minus 3 all squared plus y plus 5 all squared is equal to 2, 2, 5. DF is the diameter of the circle with center C. The angle of inclination DF is theta, and the angle of inclination of EF is beta. Angle D of EDG is equal to 43,81. DG is a tangent to the circle at D, which has coordinates 15 and negative 14. Determine the coordinates of C. Okay, so for 2 marks, that should be a very simple question for us to tackle because we don't have to do a calculation there. We can just get them from the equation of the circle. We know that C has coordinates 3 and -5. Hope that is clear. We just got that from the equation of the circle that was given. Now, determine the coordinates of F. Okay, how are we going to find the coordinates of F? I'm going to write the coordinates of C here. What we're going to do is we're going to use the midpoint. I'm going to separate them. So I'm going to say x of F plus x of D divided by 2 must give me what? Must give me x of C from the midpoint formula. Same thing must happen with the y's. Y of F plus y of D over 2 is equal to y of C. Now let's substitute what we have. X of F is unknown. What is x of D? It's 15, positive 15. Over 2 is equal to x of C, which is 3. Now x of F is simply going to be -9. Let me just put it there, -9. Let's do the same thing for y. Substitute, we don't have y of F, but we do have y of D, which is -14. So let me just immediately say that this is a minus. Over 2 is equal to y of C, which is -5. And then y of F is going to give us +4. Then I can plug it here. And it does make sense because F is in the second quadrant where the x values are negative and the y values are positive. Okay, let's address the questions. Okay, this is metric, and we are dealing with analytical geometry now. Okay, so for the tips, remember that this is recorded and we will post it on our YouTube. I'm just aware of time, okay? Please explain why we are using that formula. Okay, so the reason we're using this formula is because C is the midpoint of DF, right? Because we have the coordinates of C and it is the midpoint of FD, we are using the midpoint formula to try and find the coordinates of F. Hope everyone has answered there. Okay, I'm going to write them here in case I'm going to need them in the future. So -9 and +4. Now the next question, calculate the gradient of CD. Okay, so that shouldn't be a problem at all. We know that m of CD is equal to y2 minus y1 over x2 minus x1. Then it's just a matter of substitution. This is going to be -14 minus -5 all over 15 minus 3. Then that's just calculator work. You should get an answer of -3 over 4. That is the gradient of CD. Okay, now the next question, calculate the value of theta. So we're looking for this. And that shouldn't be a problem at all, because how we're going to go about finding theta, we're going to use this formula. Tan of theta is equal to m. Why are we using this? Because we have the gradient of that line. We just calculated it. So I'm going to say theta is equal to shift tan of what? Of -3 over 4. Now, calculator work, our reference angle is going to be 36,87. Now we know that theta is going to be how much? 180 degrees minus 36,87 degrees, which is going to give you 143,13. And that is the value of theta. Okay, now determine the equation of the tangent of DG. 4.5. The equation of the tangent of DG. Let's locate DG. Okay, so DG is this tangent here. Now, for us to find the equation of a straight line, we need either 2 points or we need what? A point and a gradient. We can find the gradient because this is a radius from the diameter. This is a radius, and remember that these are always perpendicular to each other. Right. Now, it means that m of the radius multiplied by m of the tangent will give us what? -1. Now, what was the gradient of the radius? It was the gradient that we found of CD. So -3 over 4 multiplied by m of the tangent is equal to -1, where m of the tangent is going to be +4 over 3. Now we have a gradient and we have a point D, which has coordinates 15 and -4. So we can use this equation. Y minus y1 is equal to m into x minus x1. Y minus or plus 14, because it's going to be -14, is equal to the gradient that we found. Okay, let me just try to move this down so that I can copy it nicely here. I was writing it in the wrong space, but everything is still the same. If you want to use y is equal to mx plus c, that's perfectly fine. It's the same equation. It's just that I don't like finding the c value and then substituting back in. But we're doing exactly the same thing. You don't have to change now. You can actually use that one, and then let's compare our answers. So y plus 14, why is it plus? Negative, is equal to m, which is 4 over 3 into x minus 15. So y is equal to 4 over 3x. And then we're going to take the 14 over to the other side, and we are going to have 4. And this is the equation of the straight line that we needed to find, or the equation of the tangent DG. Okay, so let's address the questions in the chat. So can you explain when do we arc a negative? Okay. So let's see here. I'm going to go back to 4.4, right? Now, what we said is, remember that our gradient was -3 over 4, right? Then we're going to simply say shift tan of -3 over 4 and check what that gives you on your calculator, okay? Because it's a negative, right? It's a negative angle. We know that we are in the second quadrant where tan is negative. That's why we said 180 minus that angle, because tan is negative in the second quadrant, and the reduction formula for the second quadrant is going to be 180 minus whatever theta is. Okay, somebody's asking me to repeat the steps at 4.5. Okay, so I'm just quickly going to run through the steps at 4.5. All I did is I said the gradient of the radius multiplied by the gradient of the tangent will give us -1. We know that when lines are perpendicular to each other, the product of their gradient is going to give you -1. That's why I have that. And we found the gradient of the radius. Right, remember, we were asked to calculate the gradient of CD. CD is the radius, if you check properly there. And I just substituted that value there. Then to find m of the tangent, you simply say -1 divided by -3/4. And this is the tangent. So this is the, sorry, not the tangent, but this is the gradient of the tangent. Once you have the equation, once you have the gradient, then you use the equation of a straight line. You can use y is equal to mx plus c. You don't have to change now and use what I use. Okay, somebody's asking me to use the equation of a straight line, but this is the equation of a straight line. This is that you want y equals to mx plus c. That's fine, I'll do it. So y is equal to mx plus c. Let's substitute what we have. The y value is going to be -14. The gradient is 4/3. The x value is 15 plus c. Then find what c is. You're going to get c as -34. Then it's a matter of substituting. Y is equal to m, which is 4/3 with an x, and the c value is -34. These two equations are exactly the same. Okay, if you're copying it down, I'll give you 10 seconds to take a screenshot there. Perfect. Now let's move on. Next question, calculate the gradient of FE for 4 marks. Let's locate FE. So we're looking for the gradient of this line. Okay, actually, let me use a highlighter. I'm looking for this equation. Or that gradient rather, not the equation, the gradient of FE. So how are we going to go about that? What we need to do is we need to find what this angle is, what angle beta is. And I don't think that's a problem at all. You must remember something. Remember that these topics are interchangeable. They can ask you a question that is related to Euclidean geometry, of which they're doing now, because we can use tan chord theorem to find angle F. Can you see that this is equal to this angle here? So I'm immediately going to say that angle F is equal to 43,81. The reason is tan chord theorem. I beg you, do not write TCT. Please give them the acceptable reason, which is tan chord theorem. Just for the sake of space and time, I'm going to write TCT, but we all know it means tan chord theorem. Okay, now when we are here, we can simply say that beta is equal to what? Beta is equal to, what's that angle that I found? 143,13. So I'm going to write this. Beta is equal to 143,13 degrees minus 43,81 degrees. And this is the exterior angle of a triangle. Now this means that beta is equal to how much? 99.32 degrees. Now we're going to use the formula. Tan of theta is equal to m. So we know that m of Fe is equal to tan of beta, which is equal to tan of 99.32 degrees. Calculator work, this should give you negative 6.09. Right, it is a negative because the gradient is actually, so this line is actually a decreasing line, so the gradient must be negative. Okay, somebody's asking me to show how it is tan chord theorem. Let me just draw that triangle. So here's a triangle EFD. Right, what does the tan chord say? It says that this angle would be equal to the opposite interior if. That's what's happening. And that's how it is the tan chord theorem. Right, 10 seconds to take a screenshot. Okay, now let's move on. Another circle with equation x squared plus y squared plus 8x minus 6y is equal to minus 5 is given. Determine the coordinates of the center of the circle. Okay, so for 3 marks, I'll give you guys a handsome 45 seconds to try and complete the square for this question so that you can find the coordinates of the center of this circle. Once you have an answer, please do type it in the Q&A section or use the chat if you are on TikTok. And don't be shy to share answers. Okay, we're going to check who got it right. And you have 40 seconds left, so please do attempt it so that we can compare our answers. Don't be shy to share your answers in the Q&A. If you're watching live from TikTok, remember to like and subscribe and follow. And please do share our page with your peers. Okay, let's look at it just for the sake of time. Another circle with the equation x squared plus y squared plus 8x minus 6y is equal to minus 5 is given. Okay, so we want the center. We know we have to complete the square. So this is x squared plus 8x. And let me just make some space. Plus y squared minus 6y is equal to negative 5. No magic so far. Okay, somebody got coordinates minus 4 and 3. Thank you so much for attempting. We're going to check now. I'm just acknowledging your submission. Now we're going to have plus 4, which is squared. How did I get 4? I said 8 divided by 2. And here I'm going to say plus 3, which needs to be squared. How did I get the 3? It's minus 6 divided by 2, which gives you minus 3. But if you square minus 3, you're going to have a positive 9. Then I have to say plus 16 plus 9. 16 and 9, this and that. Now, these are going to be our coordinates of that center. Take the x squared, square root of that, square root of y squared is just y, plus and plus, we're going to have plus in the middle. Then we have negative and positive. What are we going to have? We are just going to have a negative, because negative will give us that positive. And here we're going to have a 4 and a 3. This is equal to how much? 20. Calculator work. Now the center coordinates are going to be -4 and positive 3. Awesome work, guys. I see you guys got -4 and 3. Great work. Thank you so much for the guys who gave their answers. -4 and 3. Now, 4.7.2, show with calculations that the two circles will intersect. This is very important. They have to intersect. Give a reason for your answer. Now, firstly, let's find the distance between the two centers. Okay. Okay, before we attempt, let's address the question. So if one used the same equation you used to get the first one, is that person going to get full marks? Yes, absolutely. Everything I've written, you will get full marks. Then there's another one. So question 4.6, how come the answer is -6,09? Because I get -24,68. Okay, I think maybe your calculator is not set to degrees, or what you did is you found shift tan, and we're not trying to find the second function tan. Make sure that your calculator is set to degrees mode. Otherwise, you are going to get incorrect answers. We're not working with radians, we're working with degrees. Okay, quickly moving on. Firstly, let's find the distance between the two centers. It's this center. Okay, let me do this. So C1 has coordinates 3 and -5. So we're finding the distance between C1 and C2. That's the first thing. So the distance C1, C2, it's just the distance formula. So -4 minus 3 all squared plus 3 plus 5 all squared. And this is going to give you square root of 113. Now let's add the two radii. So this is r squared. R is going to be what? Square root of 20. Now, for the other circle, the radius is how much? We did calculate it somewhere. Let me just find it. So 2 to 5, we need to find the square root of that. And that is going to give us 15. So this is R2. R1 is equal to 15. R2 is equal to root of 20. Now let's add the 2. R1 plus R2. So 113 under root plus 15. Sorry, give me a second. Just adding these two, making a mistake. So these two added together, 15 plus root of 20. How much does that give us? That gives us, can write it in decimal. This is 19,47. Now, what is this in decimal? This is going to give you 10,63. Now we can conclude. The circles will intersect since R1 plus R2 is greater than the distance C1, C2. This is what I explained when I gave you guys those hints. I know these kind of questions can be intimidating, so please make sure that you look at a lot of past papers and you attempt these questions. Usually they ask these kind of questions on the February, March, and the mid-year exams. Not the mid-year, sorry, the prelims. That's when they usually ask these kind of questions because they consider them to be a little bit more challenging. Okay, so here's a question. So please repeat the steps after finding the distance between C1 and C2. Okay, so we're happy with this. We found the distance C1, C2. Now, from there, all I did is I found R1. Right, R1, we got it from the equation of the circle. It was given. So R squared is equal to 225, which means that R is equal to 15. That's R1. Okay, now what is R2? We found the equation of a circle and we had 20 on the right-hand side, which means that R2 is going to be root of 20. Now, all I did is I wanted to find this value, R1 plus R2. R1 is 15, R2 is root of 20. So I tried to find that. Okay. And then this is just calculator work. It gave me 19,47. Now, all I did is I compared these two distances and I said, since R1 plus R2 is greater than the distance between C1 and C2, then the two circles will intersect. And that's how I did that question. Okay, if you're taking a screenshot, I'll give you 10 seconds to do so. And then we move on. Okay, somebody's asking me to do functions. So today we are dealing with paper 2 topics because some schools in some provinces are writing mathematics paper 1 mid-year exam on Friday. So we are going to do we're going to do paper 1 on Thursday evening to prepare them. So functions will be covered on Thursday. Okay, now moving on. Now we're going to look at some trigonometry. Please make sure that you pay extra attention here. Here's a question. Given sine of theta is equal to 12 over 13, and theta lies between 90 and 360, with the aid of a diagram and without the use of a calculator, determine the size of sine 2 theta. Okay, so this is very important. Without the use of a calculator. Now, let's write our small or draw a small cast diagram. Sine of theta is 12 over 13. 12 over 13 will always give you a positive answer. Where is sine positive? Sine is positive in here and in there. Now they're saying that theta lies between 90 and 360. So it's either here, there, or there. Now we have 2 ticks in the S quadrant. That's where our diagram is going to be. Now, we know that sine is y over r. So the y value is positive 12 and the r value is simply 13. Hope everyone is with me. Otherwise, please do ask your questions in the chat. Okay, now Okay, there we go. Now, we just need to find x, and that's going to be quite easy for us because we're going to use Pythag. So x squared plus y squared is equal to r squared, and then x is equal to r squared minus y squared under a root, of course, but remember it has to be what? Plus or minus. Whenever we find that square root, we have to say plus or minus. Let me just clean it up. Plus or minus, just like that. Then let's substitute. This is going to be 13 squared minus 12 squared under square root. And this should give you 25 square root, of course. So this means that this is either positive or negative 5. It's in the second quadrant. We know that it has to assume the negative value. There we go. Okay, before we move on, there's a question. So I do not understand why you take the cast diagram. Please repeat what you did there. Okay, so firstly, let's look at this. So they're saying that sine of theta is 12 over 13. So it means that sine of theta is going to give us a positive answer. So cast sine is positive because of the 12 over 13. So sine can be positive in there or in here. The other thing that they gave us was the angle theta. It lies between 90 and 360. So from 90, from here, there, or here. Now, where do we have two ticks? It's in the second quadrant. And that's what I did to find which quadrant I'm dealing with. Okay. Now, finally, let's answer the question, the value of sine of 2 theta. We know that sine of 2 theta is equal to 2 sine theta cos of theta. As per the formula sheet, you don't have to memorize these. You can just take them from the formula sheet. 2, what is sine? Sine is 12 over 13. And then cos of theta is the x value, which is negative 5 over 13. Then it's just a matter of multiplying. And this is going to give you negative 120 over 169. 13 times 13 is 169. 2 times that 5 is going to be 10. Multiplied by 12 is 120 with a negative that was in front of the 5. Hence, our answer is negative 120 over 169. But here you can use a calculator. They're not going to know. So when they say without the use of a calculator, they don't want you to write decimals, and they want you to show all the working out. I repeat, you can use a calculator only if you don't write any decimals and you show all your steps. Okay, moving on. Okay, 10 seconds if you're taking a screenshot, and then we move on. Okay, simplify without the use of a calculator. Okay, there's a question. So in the answer, if I only write positive 5 instead of writing both sides, will I get a mark for that? So you will get it incorrect because it's not positive because of the quadrant. So x cannot be positive here. These values are negative x values. So if you say it's positive, it means that your x is somewhere here. That would be incorrect. We chose negative 5 because it's on quadrant number 2. It's in quadrant number 2, where the x values of quadrant number 2 are all negative. That's why we went with that. Somebody's asking, is it okay if we use the normal SOHCAHTOA formula to calculate x? Unfortunately, that will not work because you don't have the angle theta. Right, and they said without the use of a calculator. That's why that doesn't work. Now, coming back to this question here, we want to try and simplify this. Okay, if you've always struggled with these kind of questions, please give me your undivided attention. Now, sine of 360 minus, where is that? That is going to be in the fourth quadrant where sine is negative. Okay, because sine is negative, we're going to say negative sine of theta. I'm going to wrap it in brackets. Multiply by cos 360 plus. And remember that theta is always an acute angle. So 360 plus takes you back to the first quadrant where cos is positive. So this is going to be cos of theta. Now, whenever you are dealing with a negative angle, we're going to make it positive by adding 360. But the 360, always add it in front. Don't add it at the end to make your life easy. Then you know that you're dealing with sine 360 minus. So what is sine 360 minus? It's in the fourth quadrant where it's negative. Negative sine of theta. Okay, then the denominator. Cos of 90 plus. Where's 90 plus? It's in the second quadrant. 90 plus is in here. What do we know about cos in here? We're dealing with cos for now. Cos is negative, but it has to change to what? To sine. Wrap it in brackets. Now, tan 180 plus, that's in the third quadrant where tan is positive. So this is just going to be tan of theta. So this question was for 7 marks. Just writing this step has given you a lot of marks. So negative sine theta gives you a mark. This gives you another mark here, this and that. So you already have 5 marks out of the 7, even if you cannot simplify it further. I hope that's clear to you guys. So don't worry about simplifying. Make sure that you understand the reduction formula properly. Now moving on. This is simply going to become, I'm going to cancel what I can cancel. This cancels that. And what am I left with? I'm left with cos of theta multiplied by negative sine of theta. This is all over sine of theta over cos of theta. Okay. Somebody's asking, why don't we first change the tan before we cancel? That's perfectly fine. We're going to get the same answer. You can change it first if you want. Now, what's going to cancel here? Remember that this is the same as cos of theta multiplied by negative sine of theta multiplied by what? Cos of theta over sine theta. Then you can clearly see that this is going to cancel that. But there's still a negative here. Don't forget that negative. Cos and cos with that negative. And this is our final answer. Okay, 10 seconds to take a screenshot. Why don't you multiply the sign on the numerator? That's exactly what I did. So remember that these are now over 1. The sign multiplies on top, and then it cancels with the sign down there. That was just a question in the Q&A. Okay, moving on. Okay, so there are more questions. Why does the answer have a negative? Okay, great question there. Now, firstly, these two canceled each other out. We're left with a negative. Which negative? This is the negative that we're left with. Positive multiplied by negative is going to give you negative on top. And then down here, we have a positive. So negative divided by positive, it means that our final answer must be negative. Even if we follow our steps, we still have this negative. And then we said what? Cos of theta multiplied by this negative, multiply by, you invert cos of theta over sine theta. This sign cancels that sign, but the negative now is going to be in front of the cos. Hope everyone has answered now. Okay, another question. Why don't you multiply sine 1, the numerator, on the second step? Okay, I'm not too sure I'm understanding that question. If you can elaborate further, I'd really appreciate that question from the anonymous attendee. Okay, then we are going to move on. We're going to skip this question. We're going to do this one here. Just for the sake of time, we're not going to do everything. Some of the questions we will skip because we still need to cover Euclidean geometry. So we're saying, why don't you multiply sine on the numerator on the second step? So multiplying sine on the numerator. I didn't have to, because then if I multiplied those, I was going to have positive sine squared, and then I'm going to have to cancel again. Because I saw that they immediately cancel, I can cancel it out. Okay, now we're dealing with this question. Prove the identity. 2 tan x minus sine 2x all over 2 sine squared x is equal to tan of x. So try to do it with me. For 6 marks, let's see what we can do there. So we're going to say this is 2 multiplied by sine x over cos of x. So this is not the same as 2 sine x over 2 cos x. Please do not make that mistake. If you write it this way, remember that the 2's cancel each other out. Be very careful. Okay, then minus, what is sine of 2x? It's the same as 2 sine of x cos of x. All over 2 sine squared x. Hope everyone is with me for now. Now I'm going to take out a common factor of 2 sine x from the top. So 2 sine x as a common factor. I'm going to be left with 1 over cos of x minus cos of x. Make sure that you're following me every step of the way and stop me where you don't understand. Then 2 sine squared is the same as 2 sine of x multiplied by sine of x. Now let's cancel what can cancel. This and that. Okay. Now let's just arrange it properly. Then for the top, it means that what I'm left with is simply going to be 1 minus cos squared x over cos of x. This is the numerator. All over sine of x. Hope everyone is with me there. Now, if you play around with this, you're going to have, what is 1 minus cos squared? You're going to have sine squared x over cos of x, which is divided by sine x. Then this is the same as sine squared x over cos of x times 1 over sine x. What cancels the sine with the sine, but we have squared. So what we're left with is sine x over cos of x, which gives us tan of x. Okay, there's a question in the chat. On the second step, how did we get 1 over cos of x? Okay. Now, how we got 1 over cos x is I took this whole thing out. Let me just highlight it. This is what I took out as a common factor. Then what is left? It's 1 over cos of x, because remember, I always say that reversible math is correct math. When this multiplies, it's going to jump on top. The 2 is just going to be in front. Okay, I think there's a question. Yes, dear, please go ahead.
The question here, it says, where did cos x come from?
Where did cos of x come from? Okay, let me just try to address that question.
And the other one as well. Can you explain step 2 again?
Okay, all right, I'll explain step 2 and cos of x. All right, now, firstly, we had 2 tan of x. Tan, we know, changes to sine over cos. And then we have sine of 2x. That is a double angle, which is going to be 2 sine x cos x. Remember, this is the new stuff that they introduce in metric. That's where sine 2x, that's what sine 2x is going to give us. 2 sine x cos of x. Check your formula sheet, it is given there. And then the 2 sine squared in the denominator, I didn't change, I still have 2 sine squared x. Then I took out a common factor of 2 sine x. That's why I'm left with 1 over cos x with a cos x, because this can multiply back there. And then instead of writing 2 sine squared x, I wrote 2 sine x multiplied by sine x, so that the 2 sine x, the 2 sine x's can cancel each other out. Okay, once they've canceled out, all I did is I said, so for this, let me just highlight it. So for this, you find an LCD. This is the same as saying 1 over cos of x minus what? Minus cos squared x over cos of x, so that we have an LCD, because this is going to be cos of x and then 1 minus cos squared x. That's where I got this part. And the denominator, which is sine, is still there. From there, instead of writing this division line, I wrote a division sign, and I changed the 1 minus cos squared to be sine squared, the Pythagorean identity. Sine squared x plus cos squared x will give you 1. And then we change the division to multiplication, but we have to invert. So sine x over 1 is going to be 1 over sine x if we change the division to multiplication. And then we canceled, and then we were left with sine x over cos x. Then ultimately, we got tan of x, which is what they were looking for. Just like that, we are done with the trig proof. Right, then we can say LHS is equal to RHS. Because remember what we're trying to do. So we're trying to get here, and we're going to manipulate everything to give us tan of x. Okay, now there's another question. How did you get 1 minus cos squared x divided by cos x on step 3? Okay, I explained that part here. That's why we dealt with fractions in earlier grades. Okay, moving on. Determine the general solution to 2 minus sine x is equal to cos squared x plus 7 sine squared of x. Okay, that shouldn't be a problem at all. Let's see what we can do. I'm going to try and change this cos squared to what? To sine, because I have a sine here and I have another sine there. The reason I'm not changing this sine squared to cos is because I have a sine here, which will be difficult for me to try and change. So I'm going to have this 2 minus sine x is equal to 1 minus sine squared x plus 7 sine squared x. Hope everyone is with me there. Now, we're going to say that this is going to be 0 is equal to, these two, we add them up, it's going to be 6 sine squared x plus sine of x minus 1. Okay, so question, so when do we change the division sign to multiplication, our numerator? Yes, absolutely. When you change from division to multiplication, you have to invert the numerator and the denominator. Okay, now here, this is the same as 6x squared plus x minus 1, in case you don't know how to factorize sine. But I'm going to just factorize that. I know that this is going to be, we write my two brackets and say equal to 0. 6, I'm going to try 3 sine x multiplied by 2 sine x. 3 multiplied by 2 should give me 6. Sine multiplied by sine is going to give me sine squared. All right. Now I want a positive sine x. So what I'm going to do is I'm going to say this is plus 1 so that I have a 3 sine. And I'm going to say that this is negative 1. So that negative 1 and positive 1 will take me back to this negative 1. Then I can say sine of x is equal to 1 over 3, or sine of x is equal to negative 1 over 2. Okay, so the question, how did I get 6? Here, 7 sine x, and then the cos x changed to 1 minus sine squared. So one of these, negative 1 plus 7, is going to give you positive 6. That's where the 6 comes from. Okay, somebody's asking me to restart the general solution. I'm going to go over it as soon as I'm done with it. So let's just complete it first before we take it from the top. Then it's just a matter of finding shift sign. So I know that x is going to be what? 19,47 degrees plus k 360. Or what? Or x is going to be 160 degrees, comma 5. So let me just 160,53 degrees. Write it this way. 53 degrees plus k 360. Or x is going to be 210 plus k 360. Or x is going to be 330 degrees plus k 360. Right? But remember that k is an element of integers. If you do not write this, your answers don't mean anything because we don't know what k is. Okay, now let's take it from the top. Let's try to be quick here. So we're trying to determine the general solution. What we did first is we changed the cos squared. Remember that cos squared is the same as 1 minus sine squared x. Okay? And that's what I wrote here. 1 minus sine squared x instead of writing cos squared. The reason I decided to change cos to sine is because I had a sine on the left and a sine on the right. So I wanted everything to become sine. Okay? Now, once we're there, we took these two to the right-hand side. So they became positive. So the sign became positive, The 2 became negative, but there was already a positive 1. So 1 minus 2 will give you negative 1. Now, negative sine squared plus 7 sine squared will give you positive 6 sine squared. This negative sine x went to the right-hand side to become sine of x. Now, I tried to make it simple for you guys. I changed the sine squared x to just be 6x because I know most of you guys know how to factorize 6x squared plus x minus 1. You know it's just going to give you 3x minus 1, and then you're also going to have 2x plus 1. But you know that x represents sine of x. If you look, these two things look the same. It's just that one is x and the other one is sine. And then from there, all I did is I know that this bracket is going to be what? Is going to be equal to 0. So let me just make an example here. 3 sine x is equal to 1. Divide both sides by 3. Sine x equals to 1 over 3. This should be simple for you guys at this stage. We're going to do the same thing for the 2 sine x plus 1. Then we're going to find all of those values. Right, so the first one is where sine is positive. Okay. Now, the 1 over 3, remember that sine is positive where? In the first and second quadrant. So the 1 over 3 gave you 19,47. It's in the first quadrant. It's an acute angle. And then what we did is we checked where sine is positive again. It's in the second quadrant where it's going to be 180 minus the reference angle, which is the acute angle. And then we got 160,53. And then these ones are for the negative part. Remember that side of x is negative a half. Then where is sine negative? In here and in there. So what we did is we found sine of a half, which is going to give you 30 degrees. But we want where sine is negative. That's why we say 180 plus 30. That's how we got the 210. For the other part, it's going to be 360 minus 30, which gives you 330. And then finally, we say k is an element of integers. Right. Now, somebody's asking, where did the 2 go for 2 minus sine x? The 2 went to the other side. Right. When it comes to the other side, it's going to be negative 2. Here is a positive 1 with a negative 2. I explained that part. Next question says, why do we say K 180 for tan, but not to sine and cos? That is a brilliant question. We need to remember that the sine and sine, cos, and tan graphs, when they repeat each other, it's not the same. So for tan, what you're going to have is asymptote at 90 and negative 90 like that. So we're going to have, so at 0 degrees, it's going to be 0 here. And then negative 45 is going to be negative 1. And then 45, it's going to be positive 1. So the tan graph is something that looks like that. Now, this is negative 90, and this is positive 90. Right? From here, the graph is going to repeat itself. So every 180, so 90 plus 90, every 180, the tan graph repeats itself. But for a sine or a cos graph, so you're going to have something that looks like that. Now, on this side, you're going to have the same thing. So this is 90, 180, 270, and 360. So every 360 degrees, the graph is going to start repeating itself because it's going to go up, come down, and back up. That is why for sine and cos, it's 360, and for tan, it's 180 because of repetition. Okay, why do you think the other way they in the middle before the... Could use quadratic. So here, definitely you can use quadratic equation to make your life simple. I'm going to just try and clean this up. If you're not too comfortable with factorizing, you can use the quadratic formula. That will work, and you're not going to get penalized for that. It does, however, take time. So do make sure that you're comfortable with substituting quickly if you're going to use the quadratic formula to try and simplify this. I do urge you to use it if you're not too comfortable with factorizing, but you will not get penalized. Okay, let me just zoom out in case you want to take a screenshot quickly. Give you 10 seconds for that, and then we move on. Perfect. Now moving on to Euclidean geometry. I know we are moving a little bit fast, but we had to cover 3 topics. This is the last one for today. Now, for us to deal with Euclidean geometry, we usually use the Dr. Cape Town approach, but our C is going to be divided into 3. So this D here would stand for diameter. Diameter. Now, how does that help? So let's say we have this kind of a circle, and that's a diameter. We know we can use angles in a semicircle where this is going to be 90 degrees. That's how a diameter helps. Now, for R, this would be a radius. So this is when we have this kind of a theorem. So we know that a radius will cut this chord into 2 and it's perpendicular there. Now C3. So C3 would be cyclic quad. Center and any chords. Okay, so for your cyclic quad, you need to remember 2 things. You either have the bow tie method, okay, where these 2 angles are equal because of angles in the same segment. Or you have a cyclic quadrilateral that looks something like that, where these opposite angles add up to 180 degrees because of opposite angles of a cyclic quadrilateral. Or alternatively, if you have this, the exterior angle of a cyclic quad being equal to the opposite interior one. Okay, now for the center, what we're looking for is this kind of a diagram. So let me just erase chord so that I have some space. So I'll write chord here. Now for the center, this is when we have, okay, just clean it up a little bit. Okay. Now we know that if this is 2x, this is x. Angle at the center is twice the angle at the circumference. Okay. Now, what I'm going to do is I'm going to take the very same figure. I'm going to move this point here. I'm going to move it there. Check what's going to happen. We still have our center. And this is still 2x. But I'm moving this point there. Now check what's going to happen. Because we've just moved it. Okay, somebody's asking me to increase the size of the drawings. Let me just do this so that you guys can see clearly. This is still x. Angle at the center is twice angle at the circumference. They can also move around. They can also move that point to be somewhere here. Check what's going to happen now. We still have a center. Now, this is still 2x. Then let's move that point here. If that's 2x, this is going to be x. So they're not always going to give you something like this, especially in metric. But we know they mean exactly the same thing, okay? Now, that was for the center. And then for the chord, what we need to look at is what? The tan chord theorem, okay? Or angles subtended by the very same chord. You are looking for everything that has to deal with chord. Okay, so cyclic quad, center, and chord. Now, the P would stand for parallel lines. This is when we use the X fuzz. Okay, with an underlining and a full stop. The X would be these angles being equal. These are vert up, right? Acceptable reasons. For the sake of time, I'm just going to say vert up, but we know this is vertically opposite angles. Then if provided that these two lines are parallel to each other, these two angles will be equal. And this is corresponding. Then the U, provided that these lines are parallel, these are not equal, but they're supplementary. I'll just say plus 180 because they add up to 180. These are co-interior angles. Then the Z, the most easiest one, provided that these two are parallel, these are going to be equal, and these are alt angles. For the straight line, those are angles on a straight line. Let's say we had something that looks like this, theta, alpha, and beta. We know that theta plus alpha plus beta will add up to 180 degrees because of angles on a straight line. Now the dot is angles around a point. Let me just increase this and say, actually, let me say this. Let me say this is going to be phi and x. We know that theta plus alpha plus beta plus phi plus x is equal to 360 angles around a point. And then for t, these are tangents. We need to remember that tangents from the same point are equal in length. And that's how we use Dr. Kepta. So what we try to do is we try to fill up the diagram with as much information as we possibly can from Dr. Kepta. Okay. Now, let's attempt this question. You are given a circle PQRS with center O. Prove the theorem that states angle P plus angle R equals to 180 degrees. Okay, if you struggle with proofs, make sure that you listen to this one. So the first thing that we're going to do is we're going to construct OS and OQ. You have to construct. You get a mark for constructing. That's the first step. So I'm going to say, construct radii OS and what? And OQ. Then I'm going to separate this. I'll call the smaller angle O1 and I'll call the bigger one O2. Now, what do I know? Remember, we just dealt with this reason here. This part. Can you guys see it? Here. I'm going to highlight. What can we say? We can say that O1 is equal to what? Is equal to 2 times whatever angle P is. What's the reason? Angle at center is twice angle at the circumference. I beg you, please write the acceptable reasons, right? Now, the next thing that we're going to do is we're going to say O2, angle O2 is going to be what? It's going to be 2 times whatever angle R is. The same way we dealt with this one. Let me just erase this. Let's look at it. So O2, this angle is twice whatever R is. Angle at the center is twice angle at the circumference. Now, what do we know? We know that angle O1 plus angle O2, not Q, angle O, let me just quickly fix that. It's not Q, it's O. So angle O1 plus angle O2 must add up to how much? 360 degrees. Why? Those are angles around a point or angles in a full revolution. Now let's substitute. What do we know about O1? It's the same as 2 times angle P. What do we know about angle O2? It's the same as 2 multiplied by angle R. Then you divide throughout by 2. Angle P plus angle R is equal to 180 degrees. And just like that, we are done. So never ever skip this question. An easy 5 marks. Okay, let's move on. The line ABC is a tangent to the circle at B, and ADE is a tangent to the circle at D. So we have 2 tangents, and we know that tangents from the same point are equal in length because we've just dealt with Dr. Kepta. They said GB is equal to GH, then BAD is equal to 68, and GDB, so angle D of GDB is equal to 45. It is further given that angle B of ABD is equal to X, and angle G of BGD is equal to Y. And then angle H of GHD is equal to Z. Now, the very first thing, it says calculate the value of X. Okay, this is for 3 marks. I'm going to let you guys attempt this question. I'll give you 45 seconds to attempt it. So we're looking for the value of X. As soon as you have an answer for me, please do post it in the chat or the Q&A if you are on Zoom. Please make sure that you attempt it. We are now doing 9.2.1. Calculate the value of X. I want you guys to attempt it. Remember the reasoning that I gave you guys. Right, Dr. Kepta. You have 30 seconds left if you're attempting it. And as soon as you have an answer, please do share it in the Q&A or in the chat. Okay, I got 2 answers. They're both 56. Thank you so much to you guys who have attempted this. We got 56 from 2 people. So if you're still writing it out, you have 10 seconds left. As you're working it out, please don't forget to subscribe, like, and share our content. Somebody got X to be 23. We're going to check which one is correct. Thank you so much for attempting. Okay, perfect. Let's quickly check. The very first thing that we can see is that these two are equal in length because they originate from the same point. And we discussed it that tangents from the same point are equal in length. Now we're dealing with an isosceles triangle. It means that this is also X. These are angles that are opposite equal sides. Now we can simply say, that 2x plus 68 is going to give us 180. So x plus 68 equals to 180 degrees, interior angles of a triangle. 2x equals to 180 minus 68. Then divide both sides by 2. X is equal to 56 degrees. Hope everyone is with me there. Thank you so much, guys, for attempting this question. To the person who got 23, I hope you can see your mistake because the correct answer is 56. Remember to try and use Dr. Cape Town for these questions. Now, the next question, write down, we don't have to calculate, with a reason, the value of y. What is y going to be? You can quickly type it in the chat if you know the value of y. You're not supposed to calculate, you must just state it. Absolutely. Thank you so much for that answer. Y is 56 degrees. Why is that? With a reason, remember. Tan chord theorem. And we get 1 mark for that. Now, the next question, calculate the value of z. Let's check. So we're looking for this now. The value of z. This is for 2 marks. I'm going to give you guys 45 seconds to attempt it by yourselves. We're looking for the value of z. So please take this opportunity to attempt this. Okay, I've already gotten an answer for z. Somebody's saying that z is equal to 124. I'm just acknowledging your answer. I'm not saying it's wrong or right. Thank you so much for attempting it. If you're working it out, you have 15 seconds left. If you have a different answer, please do share. Okay. 124. Going twice. All right. 3 people are saying z is equal to 124. Okay, let's quickly check. Let's see if we're sitting with the same misconception or if z is equal to 124. Somebody else got z to be 101. Okay. Now, the first thing that we need to remember here is that we found y. We said y is 56. because of the tan chord theorem in 9.2.2 here. Now we can find B using interior angles of a triangle. And if you find angle B, you're going to get 79 degrees. Check it now on your calculator. So if you said 180 degrees minus 56 minus 45, that should give you 79 degrees. Now we need to remember something, that GBD is equal to what? Sorry, not equal to, but GBD plus GHD must add up to 180 degrees, opposite angles of a cyclic quadrilateral. They are supplementary. Now it means that GHD is equal to 180 minus 79, which is going to give you 101 degrees. So the correct answer was 101. But thank you so much, guys, for attempting this question. I hope it makes sense to everyone. Hope everyone can see their mistakes. Remember, this is the way we learn math. We make mistakes and we correct them. Okay, so somebody's asking, so what about the information we are given in the statement that B is equal to X? Let's see. Is it given that B is equal to X? No, they did not say that B is equal to X. So they said ABD. So ABD is this angle here, because we come from A, we go to B, and then we go to D. So that B is the one that is equal to X. Okay, did they mention that it's a cyclic quadrilateral? Because it's touching the circle at 4 points, it is a cyclic quadrilateral. So with the rules, with the exam guidelines, they usually say that this is the only thing that you can assume when a quadrilateral is inside a circle and touching it at 4 times. Even if it's not given in the statement, this is the one thing that you can assume. Okay, because it's asking how did we get 101? Please do check. We found B first and we said B plus H will add up to 180 degrees. And then we took this to the right-hand side. And we said 180 minus 79. And that's how we got 101. Okay, perfect. Let's move on. Hence, calculate the size of C, the size of angle C. Okay. And it's a hence question. How would we go about that? Okay. So I'm going to say HDG is equal to 45 degrees. Equal chords, equal angles. So remember that these two are equal. Check here, this and that. So it means that this must be 45 degrees. Hope everyone is following there. Then we can say CGB must be equal to 90 degrees. CGB is 90 degrees. Why? That is the exterior angle of a cyclic quadrilateral. Now we can conclude that C is equal to 45 degrees. What's the reason? Exterior angle of a triangle. because we found this to be 90. Remember your grade 9 and 10 statements. They are very important. And just like that, we are done with finding the value or the size of angle C. Okay. Here's another one. In the diagram, O is the center of the circle. A, B, C, and D are points on the circumference of the circle. EOB is a straight line with E on AD. AB is equal to BC, and B2 is equal to X. Now, show that O1 is equal to 180 degrees minus 2x. That shouldn't be too much of a problem. Let's see what we can do here. I'm already seeing radii. I have OC, which is a radius, and then I also have OB, which is a radius. Now, ABCD is a cyclic quadrilateral. Okay. Now we need to show that O1 is equal to 180 minus 2x. So what I'm going to do first is I'm going to say that BCO is equal to x. Why is BCO x? Because this is an isosceles triangle. So this is going to be x. These two are radii. They're equal to each other. So angles opposite equal sides, or angles equal opposite radii. Now we can see that BCO, sorry, not BCO, but BOC, because that's what we're looking for. O1, BOC is equal to 180 degrees minus 2x. I've skipped the step. I know a lot of people will fight me there, but remember that O1 plus x equals to 180 degrees. Interior angles of a triangle. O1 is equal to 180 degrees minus 2x. And just like that, we get our 2 marks. Okay, so there's a question that I missed. So I still don't understand how we got C to be 45. Let's quickly go back and see. Hence, calculate the value of C. Okay, so what we did first is we tried to find HDG, right? So HDG would be this angle here. And because these two are equal to each other, then we know that this will be 45. Now, if that is 45, what do we know? We know that CGB. So CGB is going to be 90 degrees. That is what? That is going to be 90 degrees. So here's CGB. Now, if you're still lost, I urge you to find what this angle here is. You can find it by using interior angles of a triangle. Sorry, angles on a straight line. I correct myself. Angles on a straight line to find what this is. And then you can use interior angles of a triangle. But what we did is we used the exterior angle of a triangle. And then this should work out for you. I hope that makes sense. Okay, this is where we were. Calculate with a reason A1 in terms of x. So calculate A1 in terms of x. So this is not a bow tie, unfortunately, because this line BE is not touching D. So if the line was coming this way, then we would have a bow tie. I hope I'm clear there. But let's see what we can do. I'm pretty sure we can still solve the question. remember we found O1 to be 180 minus 2x. Now we're looking for A1. And I can see something here that A1, this is this case here. Let me just go back to my Dr. Cape Town. Remember, I played around with these things. It's this case. I'm going to highlight it. Just put this at the back of your mind. Check what's going to happen. So that's the problem with Euclidean geometry. If you don't see it, you get it wrong. But let me just highlight. It's not a bow tie. Please be very careful. It's not a bow tie. So imagine this point A. If it was somewhere here, it would be like that, where A1 would be 2 times O1. But what we did is we moved it to that point. So the same reason must still apply. That's why we can say angle A1 is equal to 90 minus x. Angle at the center is twice angle at the circumference, because we have the angle at the center. The one at the circumference is going to be whatever, it's going to be half of whatever the angle at the center is. Okay, no questions. I think everyone is covered. Okay, now let's look at these two here. Show that EB bisects ABC. So show that EB bisects, let me clean it up. EB bisects ABC. So EB bisects ABC, ABC. Let's check. Where is EB? This is the line EB. It's saying it must bisect ABC, meaning that B1 must also be equal to whatever B2 is. That's what we need to prove. I'm going to start here. This is, okay. A1 is equal to C1, right? And we know that this is equal to 90 minus x. Opposite sides, so angles that are opposite equal sides. Here, it's given. These two are equal. AB is equal to BC, meaning that A1 is equal to whatever C1 is. And we did find what A1 is. Then let's find, we know that B1 must be equal to how much? Must be equal to x. So the sum of angles in triangle ABC. Right, if you're not too sure, always write it out for yourself. C1 plus B2 plus B1 plus A1 is equal to 180 degrees. And check what it's going to give you. You're going to be trying to solve for B1. Take everything to the right-hand side. You do know the value of C1. You do know the value of B2. You do know the value of A1. B1 is going to give you X. Then we can conclude. Just going to erase that. I was just showing you how I got B1 to be X. And we can conclude that B2 is equal to B1 because they're both x. And finally, EB bisects A, B, C. And just like that, we are done with that question. It wanted us to prove that it bisects, and that's exactly what we did there. Okay, now we have about 3 minutes left. We won't have enough time to start another question, but I'll give you guys a minute to maybe ask any questions that you might have or any points of clarity if there was something that was not super clear. So please utilize this time to ask any questions that you might have. Otherwise, if you don't have any questions, I will see you guys on Thursday in preparation for Friday's exam if you are writing your exam this coming Friday. If you're not writing this coming Friday, please still join because we're not going to do paper 1 again before exams. It's only this Thursday. And remember, once again, please do share the link in your school group with friends, with family. Share it with whoever might need it. Don't forget to subscribe, like, and share our content. So please help us grow our community so we can keep bringing you top quality tutoring sessions. Okay, somebody's asking me to go through Dr. Cape Town again. Not a problem. I'll quickly look at Dr. Cape Town. So I said that D would stand for the diameter. When this is a diameter, then we know that this angle is going to be 90 degrees because of angles in a semicircle. Okay. Now, R would stand for radii or radius. Now we know that a line from the center going to the circumference of the circle would be a radius, and it's going to bisect the chord at 90 degrees. Now C3, we say cyclic quadrilateral, center, and chord. So for cyclic quadrilateral, we are going to look at angles in the same segment here. Then here we're going to look at opposite angles of a cyclic quadrilateral. We're also going to look at exterior or the external angle of a cyclic quadrilateral. Then for your center, we're going to look at angle at the center is twice angle at the circumference. And please remember that they can move this point around. See what I did here? So it started there, then I moved it here, and then I moved it there finally. That would be the center. Now, P would be your parallel lines where we used the X fuzz. This is what we learned in grades 8 and 9, geometry of straight lines. And then the T would be the tangent, where tangents from the same point are equal in length. And then you would have an isosceles triangle if it is somewhere closed. If you have a chord, then you would have an isosceles triangle because these two angles would also be equal. All right. It is now just a few seconds before 8 o'clock. I think we can all end here for today. Thank you so much for taking your time to come and join this session. I will see you guys all on Thursday. And please do stay tuned to our YouTube, our TikTok, where we will be posting the links to the next session. I will see you all on Thursday. We will be looking at the core topics of paper 1. So make sure that you do not miss Thursday's lesson. The topics that will be covered are going to be, I'll tell you now, it's going to be differential calculus, functions, sequences, and series. I know calculus is a big one. Functions is also a big one. Sequences and series is a very easy one that I don't want us to mess up at all. Right. Other than that, we are all going to end here for today.